So next one, so fitting a parabola or second degree polynomial. Okay, here also they may ask that one, derive normal equations to fit a parabola. Same like a straight line. So what you learned in straight line, same as it is here also same thing. Only the difference there and here is, there it is having a linear one and here it is a non-linear one, and in other words we'll say that this is particularly second degree polynomial. So second degree is nothing but simply what we'll write, so ax square, right? Ax square plus bx plus c, right? So ax square plus bx plus c, so this one we'll write. Okay, second degree polynomial. Here also same like as that one. So we'll take that one second degree polynomial or simply parabola. So fitting a parabola is nothing but we'll choose as the form y is equal to ax square plus bx plus c. So let it be choosing as 1. So or in other words, some of the cases or some of the others follow that a plus this one simply we write it as bx plus cx square. So like this also they will write. Okay, any form we can. So here degree polynomial 2. So this is degree 2. So for that we are saying as polynomial. Okay. So in other words, quadratic also will say that. So first we will choose that one as the equation 1. So the equation of the parabola is, or the equation of the second degree polynomial is y is equal to a plus bx plus cx square. And next to that parabola or second degree polynomial passes through the point xi yi, right? It passes through the point xi yi. We are defining that one, right? Xi yi, and simply by substituting that what we'll get here, it is passes through that one is nothing but obviously it satisfies that one. So simply what we can write, a plus bxi plus cxi square. So yi is equal to a plus bxi plus cxi square. So this one take it as equation 2. So let it be taken as 2. Okay, so this is the one. So first we are choosing the general one. The equation of the second degree polynomial or the parabola is y is equal to a plus bx plus cx square, and this passes through the point data, given data xi yi. So it means if you are saying it passes through that one is nothing but obviously it satisfies the given curve. So that's why simply we are writing yi is equal a plus bxi plus cxi square. This is the actual one and this is the what we are calculating one. Okay, so obviously exact one and calculated one means some error will exist, right? So that error how we are defining, ei is equal to, so that one only here we wrote. So ei is equal, the error ei between the observed and expected value of yi is defined as yi minus of a plus bxi plus cxi square. So this one we are defining as error. So ei is equal, so what we are defining, yi minus of a plus bxi, yi minus of a plus bxi plus cxi square. So this is yi minus a plus bxi plus cxi square. So this one we are defining as error, right? So cxi square. And next our intention is to here fitting a second degree polynomial or fitting a parabola. That's that one we are discussing here. It means we need to minimize the errors, for that we are using method of least squares. So it means that sum of squares of these errors has to be minimized. That's why we are writing as sum of squares of these errors is defining as e is equal, sum of squares, summation is nothing but sum and squares is nothing but square these errors. So error is nothing but what, yi minus a plus bxi plus cxi square whole square. Okay, sum of squares of these errors, okay, is we are defining as e. It means simply we are expanding that summation. It means first if you substitute I is equal to 1, so what we'll get if you substitute y is equal to 1, y1 minus of a plus bx1 plus cx1 square. So y plus a, y minus of a plus bx1 plus cx1 square, right? So by substituting in place of I as 1, so y1 minus of this one. So that's why here I wrote y1 minus of a plus bx1 plus cx1 square whole square. And next in the same way second one, y2 minus of a plus bx2 plus cx2 square whole square. And in the same way, if you substitute in place of I as n, so what we are getting here is yn minus of a plus bxn plus cxn square whole square. Our intention is to here minimize the errors. So minimizing error is nothing but what we are doing. We are applying partial derivatives of what we need to calculate. Here, what are the constants we need to find here? A, B and C. It means what we have to do it here, dou E by dou A is equal to 0, and next dou E by dou B is equal to 0, another one dou E by dou C is equal to 0. So that's why simply we write here it is we need to calculate E with respect to A partial derivative, and E with respect to B and E with respect to C we have to apply partial derivative and then equate it to 0. Then we get three normal equations. So you need to remember that if the given curve consisting of two constants, two normal equations, that one we saw in straight line. In the same way, it is consisting of three constants, then it is coming under parabola or second degree polynomial, and it should consisting of three normal equations. Okay, so here it is, first we need to apply partial derivative to this one with respect to a and then equate it to 0. So with respect to a we are applying means first what we'll get, this one entire one you can treat as a square, then simply what we can write 2 into this total one will get, right, y1 minus of a plus bx1 plus cx1 square. So a plus bx1 plus cx1 square, cx1 square whole square and a whole power 2 minus 1. So 2 minus 1 is nothing but 1. And again we need to apply derivative of this one. So y1 derivative is 0. Why? Because we are applying with respect to what? A. So for that here it is having what about remaining minus a derivative dou by dou a of a is nothing but what will get 1, and rest of the elements become 0. Why? Because with respect to a we are applying partial derivative. It means simply what we got it here with respect to a, if we apply first term what we are getting minus 1 into 2 is nothing but minus 2. Okay, so minus 2 into y1 minus of a plus bx1 plus cx1 square. So of course here it is having minus, and this is also will get it as minus, and here also minus. It means overall what we'll get here it is having, so minus 2 into this one and minus 2 into this one, minus 2 into this one. Okay, so there it is minus we took common, and that's why we wrote plus. Okay, so our, if you observe this in the entire term what we have the common one, so here it is having minus 2 and here also minus 2 and next here also minus 2. So we have to take minus 2 as common one, and then we have to send that one into right hand side, then it becomes 0. Why? Because 0 by minus 2 is 0. And what we have remaining here it is having y1 minus of this one, y2 minus of this one, and yn minus of this one. So just we are keeping this y terms left side and sending remaining terms to right side. So what are the remaining one? Y1 plus Y2 plus and so on plus Yn is equal, by taking this one into right hand side, what will get? A plus Bx1 plus Cx1 square, A plus Bx2 plus Cx2 square, A plus Bxn plus Cxn square. So if you observe that here it is having A and here it is having A and here also having A. It means A plus and so on plus A. And next if you are taking two second terms, bx1 plus bx2 plus and so on plus bxn, in that b is the common one. So if we take b as common one, what we'll get? X1 plus x2 plus and so on plus xn. In the same way, if you are taking these terms, cx1 square, cx2 square and so on, so here which one is the common one? Here it is having c, and here it is having c, and here also it is having c. So c we are taking common, and then what about remaining? X1 square plus x2 square plus and so on plus xn square. Now we are writing simply that one in summation notation. Summation I equal to 1 to n yi is equal, how many a's here? A plus a is nothing but 2a, 2a plus 3a, 3a plus 4a, 4a plus a, 5a, 5a plus a, 6a. Like that, how many terms we are taking here? Total n terms. So for that we are getting as na. And next b as it is, and this one also we are writing in summation notation. And next plus c into, so this one also we are writing a summation notation. Okay, so this is the first normal equation. Okay, so once if you understood that straight line, obviously you can get it with parabola easily. This is, and next we are going to apply dou e by dou b. Okay, so only one thing. So here it is having, this is as usual if you apply derivative with respect to b, and next y1 derivative is 0 minus of a derivative is 0. Why? Because we are applying with respect to b. So here what we'll get, dou by dou b of b is nothing but 1, but here it is having x1. So for that here what we have, x1 is the remaining one. So here you will get x1. Okay, so that's why here we wrote, see here, 2x1 into y1 minus of a plus bx1 plus cx1 square. Of course minus we eliminated. Okay, so if you want you can write first minus for each and every term. So here it is having minus, and here also minus. Okay, and next minus 2 is the common one, we have to take that one common and take that one into right hand side, it becomes 0. And next if you multiply with x1, what will get, x1 into y1. In the same way here it is having x2 into y2. In the same way here it is having xn into yn. So that's why here we wrote x1 y1 plus x2 y2 plus and so on plus x1 xn yn. And next coming to this, here it is having x1 into this total one none. So x1 into a is nothing but ax1. That's why here ax1. Next in this term ax2, and next term axn. So for that a took we come. And next finally x1 into x1 square is nothing but x1 cube. So c1 into x1 cube, c2 is c into x2 cube, and so on. In the same way if we are taking second term also will get the same pattern. Okay, so if you see that once clearly easily you can understand that. Okay, so that is for second one. And next if you are taking that common one, same summation we are writing, and a into summation xi b xi square c xi cube. Okay, next one none. With respect to c means, again what we'll get, first if we apply derivative for that, what we'll get, 2 into y1 minus of a plus b, a plus bx1 plus cx1 square, cx1 square, and here it is having whole power 2 minus 1 is nothing but 1, and this is becomes 0, and this is also becomes 0, and this one also becomes 0. Why? Because we are applying partial derivative with respect to c. So for that minus as this, and c dou by dou c of c is nothing but 1, and what we have remaining, only x1 square. Okay, so if you apply one time derivative, we are getting this one. So that's why here we wrote 2x1 square into this one, 2x2 square into this one, and 2xn square into this one. Okay, so of course minus of with eliminated that, and then remaining we wrote. So now again you can multiply the terms, x1 square into y1, x2 square into y2, and xn square into yn. That's why we wrote here like this. And next coming to this, a into x1 square. So for that a x1 square. Next a into x2 square, and next a into xn square. So that's why here it is this term. Next one, b into x1 square is nothing but x1 cube, and next to x2 cube and so on xn cube. And next in the same way c, if you are taking c, x1 power 4. So x1 square into x1 square none. So x1 power 4. So next x2 power 4 and xn power 4. And simply we wrote in a summation notation, summation xi square yi is equal a summation xi square plus b summation xi cube plus c summation xi power 4. And by solving these three equations, so these are the three normal equations for fitting a parabola or second degree polynomial. This is second one, and next this is third one. So total three normal equations. Like straight line, how you understood, same like that we can write. No need to by audit these things also. Okay. So here it is what we are writing first. Straight line or parabola is nothing but this is the curve. If they mention, you have to choose as it is. If they don't mention, we have to take our individual. Okay. So a plus bx plus cx square, or if you want ax square plus bx plus c. Okay. So first normal equation means simply what we are applying there also in straight line. Summation y is equal, for individual constant we are writing as n. So na plus b summation x, b summation x plus c summation x square. Just we will apply first normal equation is nothing but summation for the variables. So variable this y, x, x square are variables. So for that we applied summation. For constant we applied n. And next normal equation how we are getting, Just we are multiplying with x, right? In straight line, what we did, same as it is done, x multiplication. So here a summation x plus b summation x square, and next c summation x cube. Just we are multiplying the entire one with x. So c summation x cube. And again, if you multiply this one with x, you'll get third one. So here it is having xy. So it means x into x is nothing but x square. So x square y is equal to a into summation x square plus b into summation x cube. Okay, b into summation x cube plus c into summation x power 4. Okay, so these are the three normal equations. Don't buy hard it. If you buy hard it, obviously you'll write wrong. Okay, so here it is simply first one normal equation. We are applying summation only for a. We are writing constant n. Next, we are multiplying entire one with x. Summation xy, a summation x, b summation x square, c summation x cube. And next one, we are multiplying with x. Already here it is having x. If you multiply that one with x square, and x square into x is x cube, and x cube into x is nothing but x power 4. So these are the three normal equations. For fitting a second degree polynomial or straight line, the three normal equations are these. Okay, and by solving these equations, we'll get a, b, c values. And finally, we have to substitute those values in what we chose in the form. That is the required second degree polynomial or parabola, okay, of best fit. Okay, so this is the one derive normal equations to fit a parabola. Okay, none. So next one, let us see the problems on that. Fit a parabola to the data given below. Okay, so what we said first, as usual, like a straight line, first we have to write that one as, if they mention the form, we have to take that form. If they don't mention, we have to choose our own form. Here they didn't mention anything, so that's why we chosen the form. Let the equation of the parabola be. If they mention parabola, we write parabola. If they mention second degree polynomial, we write a second degree polynomial. Okay, so what they give, that one will write. Okay, here they give parabola, so for that we wrote parabola. So if they mention second degree polynomial, in that we write second degree polynomial, and y is equal to a plus bx plus cx square. Immediately what we have to write, to fit a parabola or second degree polynomial, we require normal equations. Those normal equations are from, simply we got these three normal equations. Okay now. So first what we are writing, summation y and a, c, b summation x, c summation x square. And next we are multiplying with x. So x here and a summation x, already x here, so x square, and this is x cube. And again we are multiplying with x, this one, a x summation x square y, a summation x square, summation x cube, and summation x power 4. So these are the three normal equations. Now we need to calculate all these values. Okay, so all these values means, first n, we have to know that n is representing what, number of values. So how many values they give, 1 2 3 4 5. So it means n is equal to what, 5. And next, what we need to calculate, these all values we require. So from the given data, so x values we know that, and y values we know that. So that values we have to take 1 2 3 4 and 5. So these are the values of x they give, and y values what they give, 10 12, and next one what they give, 8, and next 10 14. So these are the values they give. Next, what we require, first equation onwards you can see that summation y is nothing but, just by adding this one we'll get summation y, and summation x is by adding x values we'll get summation x, and x square we require, so it means x square. So x square is nothing but, what we have to do it, we have to do squaring of these numbers. 1 square is 1, 2 square is 4, and 3 square is 9, and 4 square is 16, and 5 square is 20. So this is x square. And next, x cube is nothing but, and next what we require, none. So xy we require, x square y we require. So in 1 by 1 you can calculate x square, x cube, x power 4 we require. It means cubing of this one, 1 and 4 into 2 8 27 and next in the same way 64, and next this is 125. This is x cube terms. So it means by adding these all values we'll get summation x square, and next by adding all these values we get summation x cube, and next in the same way x power 4 we have to do it. X power 4 is nothing but 1 power 4 is 1, 2 power 4 16, and 3 power 4 or 27 into 3 81, and next 4 power 4, so this is 16 to 56. Next this is 625. So by adding all these values what we'll get summation x power 4. See next x square we got it, x cube we completed, x power 4 we completed. This all okay completed. Now coming to this side. So xy are required. So xy, and next one x square y. So these are we required. Xy is nothing but we need to multiply these two terms. 1 into 10, 10, and next 2 into 12, 24, and next 3 into 8. So this is these two. Okay. Next 4 into 10, 40, and 5 into 4. So 4, not 4. This is 14. So this is 70. And next x square y is nothing but you need to multiply these terms. Okay, so you need to multiply these terms, then you get summation x square y. Okay, so and after getting these all things, simply we have to substitute those values in these normal equations. You can see that what we got it these values here. So here it is, these are the values we got it, right? So here simply we calculated x. This is the given data we chosen, and by also we took from given data, and x square is nothing but just we did squaring x cube, x power 4, xy, and x square y. And next the normal equations to fit a parabola we get. So it means here it is, these are the summations. Okay, if you see that these are the summations. So up to this one they gave we calculated, and these are all the summations. This is summation x, and this is summation y, and this is summation x square. It means how we got it just by adding all these values. And next summation x cube, and next one summation x power 4, and next summation xy, and this is summation x square y. So these are the values we got it. Now to fit a parabola, what we require, what are the normal equations we chosen? First one, summation y is nothing but 54 is equal to NA. N is nothing but number of values. How many values? 1, 2, 3, 4, 5. So for that 5a. And next b summation x. Summation x how much? 15. So 15b. And c summation x square. So x square is 55c. Next summation xy, how much? 168. So 168. And next coming to this, here what we wrote, that one, a summation x plus b summation x square plus c summation x cube. So this is x cube, so 225c. Next 640. So this is summation x square y is equal to a summation x square. So this is summation x square. So a summation x square, b summation x cube, and c summation x power 4. Same like a straight line, there it is having two equations, here three equations. You have the equations mode in your calci. So simply we get these values by solving that, we'll get a, b, c. After getting that, don't forget it, you should substitute those values here. So in place of a, b, c, what we chosen, a plus and b into x plus c into x square. C value what we got it. So this is the required curve of best fit. Okay, so like this we have to substitute. So this is the way. So there is no much difference there and here. So there it is having two constants we calculated, and here we calculated three constants. So three constants we calculated. Okay, so this is the one. Finally, on simplifying the above equations, we got it as a is equal minus 14, b is equal 3.6857, and c is equal 0.7142. And we substituted those values here. Correct. Next, see here previous problem we chosen y is equal to a plus bx plus cx square. But here it is what they mentioned, y is equal to ax square plus bx plus c. We take curve of the form y is equal to ax square plus bx plus c from the following data. So these are the values they give, x values as well as y values. Okay, so x y values they give. So these are the different values of x and y. Okay, so here it is. First, this is the equation we have to choose. So this is the equation we wrote. Let the equation of the parabola or the second degree polynomial is y is equal to x square plus bx plus c. Constant may be interchanged. Okay, there is no change the way of writing normal equation. So how to write that one? First, our first equation how we are writing, just we are applying summation for that, right? Summation y is equal to a summation x square plus b summation x, b summation x plus nc. So alone one constant, that constant we write n, and next we need to multiply with x. So summation xy is equal, what we'll get, a summation, just we are multiplying with x cube, x, so x square already there, so for that we'll get x cube, and here it is having x into x is nothing but x square, and next simply what we'll get, c summation x, and next again we need to multiply this one, summation x square y is equal, simply what we'll get, a summation x power 4. So this is the normal equation we'll get, a summation x power 4 plus b summation x cube and c summation x square. So these are the three normal equations we got. Okay, and we have to calculate these values. So already x values we know that, and y values we know that. What about n? So n is equal to how much? 4. Why? Because 4 values are there. So 1, 2, 3, 4. So n is equal to 4. So n is equal to 4, and we have to calculate x values is nothing but summation x by adding these values will get, and summation y by adding these values will get. Summation x is equal, and next summation y is equal. By adding these values we'll get these values. Okay, then we have to calculate x square, x cube, x power 4, and next xy, x square, y. All these values we need to calculate, and we have to substitute in the values in the normal equations. See here, so same process we did. So normal equations we wrote, and immediately what we calculated here, x values, y values, x square, x cube, x power 4, xy, and x square y. How we got those values? See, there it is. How we got it, that one? So x values were already they gave in the problem, and y values also they gave in the problem. Okay. So by taking those values, we need to calculate. Okay. So x values what they gave in the problem, 1, 2, 3, 4. This is they gave in the problem, 1, 2, 3, 4. And y values they gave in the problem, y 6, 11, 18, 27. And by adding these values, we'll get summation x. Okay, and next by adding these values we'll get summation y. You know, so this is the given data, and now we require x square, x cube, x power 4, xy, and x square y. How we are getting x square? 1 square is nothing but 1, and next 2 square is nothing but 4, and 3 square is 9, and 4 square is 16, and x cube is nothing but, again you need to multiply with 1. So 1 into 1 1, so 4 into 2 8, 9 into 3 27, 16 into 4 64, or 1 cube, 2 cube, 3 cube, 4 cube. Next, x power 4 is nothing but 1 power 4, 2 power 4 16, 3 power 4 81, and 4 power 4 256, or 8 into 2 16, 27 into 3 81, 64 into 4 256. With that, x power 4 completed. And now what we require, xy values. So we need to multiply these two. 1 into 6, 6, next 2 into 11, 22, and next 3 into 18, 54, and 4 into 27, 108. Okay, next x square y is nothing but, so x square y is nothing but, we need to multiply these two. 1 into 6 is 6, 4 into 11, 44, and next 9 into 18, 162, and 16 into 27, 430. Okay, x square y, and by adding these things what we'll get, this is summation x we get it, and summation y we get it here, and next summation x square here it is, and this is summation x cube will write, and next one summation x power 4 will write, and next this is summation xy, and finally summation x square y. So this one will write summation x square y. Okay, so y after adding we'll get these values and we have to substitute those things in normal equations. So here it is, this is nothing but summation y, right? And this is summation xy and this is summation x square y. So those values we substitute or not. See, summation x square by 644. Of course, we didn't write. So actually, we after adding, we'll get these values: 644, 190, and 62. And this is nothing but what we wrote. This is n, and this is nothing but summation x, and this is summation x square. And next, this is what we'll get: summation x cube, and this is summation x power 4, and this is summation x into x. This is x square and this is summation x, and this one will get the value is summation x cube, and this is the value for summation x square. And by calci you can simplify these three equations, then we get the values a, b and c. After that we have to substitute those values. Some what we got the value a into x square plus b into x plus c value what we got. So those values we have to substitute, and finally we can check that whether it is we got it right or wrong. So like that you can check that one. So if you see that whatever answers we got it here by solving, this is the one we got it: y equal to 3.2619 x square minus of 1.7857x minus 4.4998. So these are the values we got it. Okay, so here it is, we have to substitute these values by taking any one. Suppose if you are taking one, 3.23 minus 1.7857 minus 4.4998. Okay, so this one. So like that you can check that one, and so most probably you may get approximated one. Some of the cases, some of the problems it may not near one. Okay, and in another cases also they may ask to find the value of x at sorry, y at x is equal to 5 or y at x is equal to 9. Already straight line what we saw. Same like that they may ask the different one. Okay, so this is one thing. And next, here it is the same the type of problems. So fitting is parabola to this one: 0, 1, 2, 3, 4, 1, 1.8, 1.3, 2.5, 6.3. Same, we are calculated